Hello, Dr. Ajay. We are honored to have you with us. Okay. Um, shall we start, Puneet sir?
Wait, ma'am, wait.
Okay, I'm waiting. Yes, should we start?
Wait, ma'am.
Okay.
Yes, ma'am, you can start.
Okay, fine. Good afternoon, everyone. Myself, Dr. Sargam Vasu from Department of Mathematics. I welcome you all to this webinar titled Numbers, Fun and Facts. As we celebrate today as the National Mathematics Day, let us commemorate one of India's greatest mathematics genius, Srinivas Ramanujan. It is said, life is a math equation. In order to gain the most, you have to know how to convert the negatives into positives. Ramanujan was such a person who could convert the negatives into positives and get the life's equation right. Ramanujan was born on 22nd December 1887 in a small town in Tamil Nadu. He displayed a natural ability in mathematics at an early age. He loved numbers. All through his life, he experimented with numbers. At the age of 13, he completely mastered a book on advanced trigonometry by S.L. Loney. By that time, he had also discovered sophisticated theorems on his own. Once he caught hold of a book titled A Synopsis of Elementary Results in Pure and Applied Mathematics. And then there was no looking back. The book contained almost 1,000 mathematical results without any proofs. And Ramanujan started off in the ocean of mathematics. And he swam and swam. But in order to earn a living, he had to work as a clerk at the Madras Port Trust. But his quest for mathematics went on. His talent was recognized by an eminent English mathematician, G.H. Hardy, who also arranged for him to travel to Cambridge University, England. There, he produced outstanding results in the area of mathematical analysis, number theory, infinite series, and continued fractions. All this without a formal education in maths. There is a famous anecdote related to Hardy and Ramanujan. Once Hardy was traveling, going to see Ramanujan in a taxi. The number of the taxi was 1729. And Hardy had remarked, what a dull number, 1729. But Ramanujan quickly pointed out, No, it is not a dull number. It is indeed an interesting number, as this is the smallest number which can be expressed as the sum of two cubes in two different ways. So, this was the expertise of Ramanujan. He made some remarkable contributions in the field of mathematics. During his very short lifespan of only 32 years, Ramanujan had compiled almost 3,900 identities and equations, including some very important partition formulae and Mach theta functions. He also became one of the youngest member of the Fellows of the Royal Society, and he was the first Indian to be elected as the Fellow of Trinity College at Cambridge. Now, we celebrate today his birth anniversary as National Mathematics Day, and we celebrate it through this webinar. We celebrate this mathematics genius, and we celebrate mathematics today. We welcome you all on behalf of the management, principal, and staff of Goswami Ganesh Dutt SD College. We welcome Dr. Ajay Kumar to this webinar. Now, I would like to request our principal, Dr. Balraj Thapar, to please give a formal welcome to the speaker. Thank you, sir.
Good morning, ladies and gentlemen, esteemed Dr. Ajay Kumar, honorable members of the staff and dear students. It's a matter of great pleasure and pride that a person of Dr. Ajay Kumar's stature and eminence is missed us as a resource person for today. His words of wisdom will be a source of inspiration and stimulation for all of us. Dr. Ajay Kumar completed his MSc Honours from Punjab University, Chandigarh in 2008. He joined ISER Mohali as PhD scholar in 2009 and was awarded PhD in 2014. He served as assistant professor in the Department of Mathematics at DAV University, Jalandhar for 5 years from 2014 to 2019. And in 2019, Dr. Ajay joined IIT Jammu, where he is presently serving as the head of the mathematics department. Dr. Ajay is the author of one book and has published 7 research papers in reputed journals. Dr. Ajay's core area of interest is combinatorial commutative algebra. The topic of the webinar is quite interesting and relevant today, that is numbers, fun, and facts. Mathematics is the language with which God has written the universe. This was said by great astronomer and physicist Galileo, and he couldn't have been more right. The snails making their shells, spiders designing their webs are countless examples of mathematical patterns embedded in the fabric of nature. Mathematics, in fact, is the base of many streams like physics, chemistry, economics, commerce, and more. Be it a cook or a farmer, a carpenter or a mechanic, a shopkeeper or a doctor, an engineer or a scientist, everyone needs mathematics in their day-to-day lives. Mathematics makes our life orderly and prevents chaos. Certain qualities that are nurtured by mathematics are the power of reasoning, creativity, abstract thinking, critical thinking, and problem-solving ability. Math puzzles encourage open-minded attitude among youngsters and help them develop clarity in their thinking. Every year, the country celebrates National Mathematics Day on December 22nd to commemorate the birth anniversary of mathematician Srinivas Ramanujan. I congratulate the Department of Mathematics for organizing the webinar on the National Mathematics Day, and I give special thanks to Dr. Ajay Kumar for being a resource person of this webinar. Thank you. Thanks a lot.
Thank you, sir. Thank you so much for the kind words and beautifully explained the importance of mathematics and the relevance of mathematics in real world. Now we welcome Dr. Ajay Kumar. Sir, please. Thank you.
First of all, I would like to thank Principal Sir for such a nice introduction. Yeah, so as you know, all of you know, we have gathered here to celebrate the National Mathematics Day, which is being celebrated every year on December 22nd, the birth anniversary of mathematical genius Srinivas Ramanujan. In this occasion, I would like to speak a few words about Srinivas Ramanujan. As Madam already have introduced many facts about Ramanujan, but I would share a few. So Srinivas Ramanujan, the greatest Indian mathematician, was born in Erode in 1887 near Madras. His passion for mathematics was sparked when he borrowed a copy of synopsis of elementary results in pure and applied mathematics from a university student. Ramanujan has many contribution in mathematics, mainly in partition theory. The famous Roger Ramanujan identity is there, and in a famous paper in 1914, Ramanujan gave a list of 17 extraordinary formulas for to approximate the number pi. So his short but extraordinary productive life ended when he was only 32 years old. So now I would like to start today's lecture. Maybe I have to share my screen. One minute. Can people see the screen now?
Yes, sir, it is coming. It is visible.
Okay, okay. So let us start today's lecture. The title of the talk is Numbers, Funds, and Facts. So why numbers? Because the numbers, the theory of numbers is concerned with the properties of natural numbers. All of you know natural numbers are 1, 2, 3, and so on. They are also called the positive integers. These numbers together with negative integers and zero form the set of integers. More especially in number theory, we are concerned about prime numbers. These are those positive integers with no positive proper factors other than 1. They are of special importance because they are the building blocks of positive integers. The meaning of that is every positive integer can be uniquely written as a product of prime numbers in a non-decreasing order. So in number theory, many times we play with numbers, and many mathematicians, what they did is they just first they guess the results by taking some examples, and then they try to prove them. And this is how this area emerged, and many conjectures came out of this area. So today we will talk about some applications of number theory. Before that, I would like to introduce the concept of congruence. The theory of congruence was developed by Gauss at the beginning of the 19th century, and the definition is this: let m be a positive integer, okay, and a and b are any two integers. We say that a is congruent to b modulo m if m divides their difference. So that is the definition of congruence. Okay. So two numbers, two integers, a and b, they are related to each other by a relation. So congruence is a relation. Okay. If their difference is divisible by m, and if their difference is not divisible by m, they are not congruent to each other. And we say in a is congruent to b modulo m if m divides a minus b. And the examples are a is congruent to 5 modulo 7 because their difference is divisible by 7. Similarly, if you take any odd number that is of the form 2k plus 1, that is congruent to 1 modulo 2 because their difference is an even number which is divisible by 2. And you can easily check that 20 is not congruent to 3 mod 4 because their difference is not divisible by 4. If you pick any integer and divide it by m, where m is a positive integer, you can calculate its remainder. Okay. And by Euclidean algorithm, division algorithm, the division algorithm, and can calculate the remainder. And a is always congruent to its remainder modulo m. By division algorithm, we all know that remainder is always greater than equal to 0 and strictly less than m. And converse is also true that if you can find a positive number r greater than 0, strictly less than m, such that a is congruent to r mod m, then r must be the remainder, because remainder is always unique. The congruencies we use actually in everyday life also. For example, in our clock, okay, 12-hour clock, we read the time modulo 12. Okay. In our clock, 13 means 1. Okay, because 13 is congruent to 1 mod 12. So time we read is modulo 12. And similarly, days of the week. Okay, if you give numbers to the days of the week, suppose we give a Sunday to the number 0, Monday to the number 1, Tuesday to the number 2, Saturday to the number 7, then again you will, if you go further to Sunday, the number should be 7, but 7 is congruent to 0 mod 7. So this week numbers are also somehow we are using modulo 7, the day of the week. Okay, there are some properties of congruence which I will not prove, but they are easy to prove. Number a is always congruent to itself. Congruent to b mod m, then b is also congruent to a mod m. Okay, because if m divides a minus b, then m divides b minus 0. So this congruence relation is a transitive relation. Mathematically, that means if a is congruent to b mod m, b is congruent to c mod m, then this relation is transitive in the sense that a would be congruent to c mod m. You can add two congruencies modulo m. Suppose a is congruent to b mod m, c is congruent to d mod m, then you can add them. A plus c will be congruent to b plus d mod m. Similarly, you can multiply them also. Congruent to b mod m and c is congruent to d mod m, their product AC would be congruent to BD mod. Okay. In particular, if you multiply a same one congruence to itself k times, then by from fifth property you will get the sixth property, that a raised to power k is congruent to b raised to power k mod m. And the last, but that is the very important property to use in the today's lecture, that if CA is congruent to CB mod n, then if you want to cancel out C, then there would be some effect on n. What is that effect? If you cancel out on C on both sides, then A would be congruent to B mod n by D, okay, where D is the GCD of the C and n. But if the GCD of C and n is 1, then you can cancel out C from both sides. So what I'm saying is, if D is 1, GCD of C and n is 1, then this result says that you can cancel out C from both sides. That means A would be congruent to B mod n. Okay. The congruencies can be a great help in carrying out many computations. For example, if you want to calculate the remainder, okay, of this term 1 factorial plus 2 factorial plus 3 factorial plus 100 factorial upon division by 12, then you can do it easily with the help of congruencies. The observation is that if you take the 4 factorial, 4, that is congruent to 0 mod 12, okay, because 24 minus 0 is divisible by 12. Okay, and if you take any other term in this expression, that is k factorial, where k is bigger than equal to 4, okay, then that this factorial will contain 4 factorial. Okay, in its expression it will contain 4 factorial, okay, but 4 factorial is congruent to 0 mod 12. Then you can use the property of multiplicative property of congruencies, that you can multiply two congruencies. 12 is congruent to 5 more 12, 6 is congruent to 6 more 12, 4 factorial is congruent to 0 more 12. You multiply all these congruencies, you will get 0 more 12. 2 factorial when k is bigger than equal to 4 is congruent to 0 more 12. And if you want to read out this expression modulo 12, so it will look like, so 1 factorial plus 2 factorial plus 3 factorial, and after 4 factorials, all factorials will be congruent to 0 mod 12. When you sum up the terms, you will get 9. This expression is congruent to 9 mod 12. But 9 is a number which is a positive number. It is greater than equal to 0 and strictly less than 12. And as I told you that the second property, if if you are if A is congruent to R mod M, where R is strictly less than M and a positive number greater than equal to 0, then R must be the remainder. That means this 9 must be the remainder. It's a difficult problem, which are looking difficult, but it is quite simple using the theory of congruencies. Congruencies also helps in divisibility. First, I would like to introduce the definition, or not the definition, this concept that any integer, if you pick any positive integer n, then you can write n as a power of b, where b is some integer greater than 1, and that expansion is called the expansion of n with base b. Okay, and this expansion is always unique, and these coefficients a0, a1, a2, am, they take the values between 0 to b minus 1. And sometimes we write this n in this notation also, am minus 1, a naught base b. So that means you are expanding n as a powers of b. And this expansion is called the expansion of n with base b. If you take base to be 2, then that expansion is called the binary expansion. Okay? And these coefficients ai's are called the digits. And usually what we study in mathematics, we use the decimal expansion. Okay, so that means you always express a positive integer n as a powers of 10. And the coefficients a0, a1 up to am, they lies between strictly greater than 0 and less than 10. They are called the digits or digits. Okay, so we can use congruencies in the divisibility. So one example is this, because you can express any number 10 in its decimal expansion, and we know 10 is congruent to 1 mod 3. And using the property of congruencies, if you multiply this congruence with itself I times, you will get 10 raised to power I is congruent to 1 mod 3. So it should be 1. Okay, so that means all powers of 10 are congruent to 1 mod 3. Now if you want to read this n modulo 3, okay, then 10 is congruent to 1 mod 3, are also congruent to 1 mod 3. So n would be congruent to sum of these coefficients, am plus am minus 1 plus a1 plus a naught mod 3. So that means an integer is divisible by 3 if and only if sum of its digits is divisible by 3. Okay, because these two things are congruent to each other. Okay, so if n is divisible by 3, then this number, this a expression am plus am minus 1 plus a1 plus a0, this would be also divisible by 3. You can check that whether a number is divisible by 3 or not. You just add up the digits in its the decimal expansion. Similarly, you can prove that a number is divisible by 9 if and only if the sum of its digits is divisible by 9. If you take a number 2, 4, 3, 5, 0, 6 and 0, 7, 6, then you calculate the sum of its digits. Because it is divisible by 3, so that means this number is also divisible by 3. But this 33 is not divisible by 9, so this number is not divisible by 9, just by using the above two properties. Similarly, one more property of congruencies is you can check whether a number is divisible by 11 or not. Just use this congruence that 10 is congruent to minus 1 mod 11. So 10 raised to power I would be congruent to minus 1 raised to power I mod 11. And then when you read this number n modulo 11, because 10 is congruent to minus 1 mod 11, and 10 raised to power m minus 1 would be congruent to minus 1 raised to power m minus 1 mod 11. So you will get expression like this. So n is congruent to a naught minus a1 plus a2 minus a3, and last term would be am into minus 1 raised to power n mod 11. So that means these two numbers are congruent to each other modulo 11. So that means this number n is divisible by 11 if and only if this expression, which is on the right hand side of the congruence, this is divisible by 11. But this expression is nothing but this is the sum of the even terms minus sum of the odd terms, okay, odd digits. Okay, so that is if and only if sum of the digits in the even position minus sum of the digits in the odd positions is divisible by 11. And that is the similar example which I gave above. If you calculate the sum of the digits in the even position minus sum of the digits in the odd position, you will get minus 11, because that is divisible by 11. So this number is also 11. Another important application of congruences is in the calendar. So the problem is if someone give you some date, okay, some date, suppose some date is given to you and someone asks you what would be the day on that date, then you can do that using the theory of congruences. Okay, so what are the things you need actually? Okay, so suppose you know the day number on 1st March, say 1st March 1600. Suppose this is known to us, and someone asks you to calculate the day number on, say, 2nd of April 2020. So how you are going to do this? Suppose some intuition is there, you should know that how many days are in between these two dates. Somehow you have to use that. Okay, how many years are between these two dates, how many months are between these two dates, how many days are there in these two dates. So you have to count all these things. Okay, but to do that countings you have to be careful, because when you count the years in a year, that year can be leap year, that can be a non-leap year. Okay, so if it is a leap year, you have to add 366 days. If it is a non-leap year, then you have to add 365 days. Similarly, you have to take care of months also, because sometimes months in months there are 31 days, sometimes there are 30 days. Okay, so all these calculations we have to do. So first of all, what is a leap year? Okay, so leap years are years which are divisible by 4. The exception is the century years. In century years, you have to check that whether that year is divisible by 400 or not. Okay, if it is divisible by 400, then it is a century. Okay, for example, 1700, 1800, 1900, these are non-leap years, while 1600 and 2000, these are leap years. Okay, and our aim is to find the day of the week for a given date after the year 1600 in the Gregorian calendar, was introduced in 16th century. So we will look for a day of the week for a given date after the year 1600. And one more convention we will use, because and as the extra day in the leap years is added at the end of February. So by convention, it is convenient to start from March, okay, rather than January and February. Okay, so in our model, we will start a month for our year from March actually. Okay, so first month can be be actually March, be April, and so on. And uh, uh, convention which we use, January 2020 is say the first month, February is the second month, March is the third month. But in our model, March would be first month, second month, May would be third month, February would be the 12th month of the last year. Okay, so convention which we will use. Okay, suppose now after this all these calculations, someone asks you to calculate the what is the day number on the 3rd of January 2020. So but for that, first you have to change this date in our model. Okay, in our model, January 2019, it would be January 2019 and it would be 11th month by the formula. Let us see that you will get later on, but that is the convention we will use, that our year would start from March onwards. Okay, as we have to use the congruencies and number theory, so we will assign numbers. Okay, so we will assign numbers to the weekdays. Okay, so Sunday is assigned 0 number, Monday is assigned 1, Tuesday is 2, and Saturday is 6. Okay, similarly we will assign numbers to the months also. So because we are starting from March, first month, April would be second month, and February would be the 12th month. Okay, okay, and there are few more notations we will use. So D denote the day of the month, M denotes the month, Y is year, C is for century, N is the nth year in that century. So for example, 1st April 1673, it would mean D is 1, is second, because in our convention April is the second month. Year is 1673, but you can always write it like 100 into C plus N. So century is the 16th century, and in that century, year is the 7330. Okay, and as I told you that if you want to calculate some day, what would be the day on a particular date, calculate the corresponding number on that day, because their days are assigned with certain numbers. And this you can do in 3 steps. Okay, step we will calculate the number, weekday number, which is denoted by dy on 1st March of any year y. Okay, so first thing is we will calculate 1st March, what is the day number on 1st March of any year y. Suppose you want to calculate 2020, and then suppose you want to calculate, you want to go to 4th of April. Suppose this is our aim, we want to calculate the what would be the day number on 4th of April 2020. So first step is you calculate the day number of on 1st of March 2020, calculate the day number on 1st of April 2020. In the third step, then you go to 4th of April. So this whole procedure is in 3 parts. To say calculate the day number on 4th of April 2020. So first step is you calculate the day number on 1st March of 2020. Then you calculate the day number on 1st April 2020. How you will go from March to April? You have to add 31 days. And then if you want to go from 1st April to 4th of April 2020, you have to add 3 more days. So this is in 3 steps. Okay, so first step is you calculate the day number y on 1st March in any year y. Calculate the weekday number on first day of any month in which you want to calculate the date, and then you calculate the weekday number of any day in that month. So let us first calculate the dy. Dy is the number on 1st March of any year y. Y we are assuming greater than 1600. So dy is the day number. Okay, it is the day number 1st March in year Y. Okay, this you can calculate from dy minus 1. Okay, suppose you know what is the day on dy minus 1 and you want to calculate what is the day number dy. Okay, so how you will do? You have to add number of days. You are there, only 1 year difference is there, so you have to add number of days in that year. So that year can be a leap year, it can be a non-leap year. So if it is a leap year, you have to add 366 days, and if it is a non-leap year, add 365 days, right? Okay, so this is the dy is the day number on 1st March year Y. This you can calculate from dy minus 1 by adding certain numbers, by days 366 or 365. Okay, but day numbers is between 0 to 6. There are only 7 days numbers we have assigned. So that means you have to go modulo. And because 365 is congruent to 1 mod 7 and 366 is congruent to 2 mod 7. So that means you can obtain dy from dy minus 1 by adding 2 or 1. You have to add 2 when y is a leap year. You have to add 1 when y is not a leap year. So in this way, you have now a method that is called recursive method. Okay, there is a recursion going out here. You can obtain dy from dy minus 1 in 1 day or 2 days. That depends on that year is leap year or not year. Okay, so but if you go on decreasing like this, starting from 1600 year, so you can go up to d of 1600, and then you can calculate dy in terms of d of 1600. Okay, you go on decreasing y from here by this method. Okay, and how many factors you will add? Years between y and 1600 plus one extra one you are adding corresponding to each leap year. dy would be d of 1600 plus y minus 1600 plus l is the number of leap years between y and 1600. We are excluding 1600 and including y, and once you know this l value of l, then you have some formula for dy, d of 1600 also. Okay, so now you calculate the number of leap years between y and 1600. So how many years are there in between? Y minus 1600 years are there. So if a year 4, that is a leap year, with exception is that should not be divisible by 100. So you have to subtract all those century years, but you have to add all those years which are divisible by 400. Okay, so once those years between y and 1600 which are divisible by 4, that number you have to subtract which those years which are divisible by 100, but some of them could be divisible by 400, so that factor you have to add it again. Okay, so that is the l is the number of leap years. Now you can plug in the value of l, and further you can simplify this expression. Because y is an year, you can write y as 100 into c plus n, where c is the century, n is the nth year. And then you can simplify this formula and you will obtain d of 1600 minus 2 times c plus n. Okay, and this thing, this notation is for greatest integer function, this square bracket, so that you must know. So d of y you will obtain in terms of d of 1600 minus 2c plus n plus greatest integer of n by 4 plus greatest integer of c by 4 mod 7. This formula depends on so this if some these numbers c and d of 1600. D of 1600, this we don't know. So here actually we will do a cheating. We know we will check the recent calendar, and we know that if you take uh, the date 1 March 2020, that is on Sunday. Okay, so that means Sunday is given to be number 0. So that means D of 2020 is actually 0. That you can check from a calendar. Put the value of D of 2020 in this expression, and that is actually 0. You will get 0 is congruent to D of 1600 minus. So because your year is 2020, so you can write 2020 at as 100 into C plus N, where C is 20, N is 20. And then you can calculate the value of D of 1600 from this expression. You will see that D of 1600 is congruent to 3 mod 7. D of 1600 was 1st March of 1600. Actually, this number is 3, so 3 is actually Wednesday. So then you can put the value of D of 1600 in the expression, and you can get D of y is congruent to 3 minus 2c plus n plus greatest integer of n by 4 plus c by 4 mod 7. Now the first step is done. Now you know the day number on 1st March of any year y. So that is the first step. So now you want to calculate the day number first of any month in that year. Okay, suppose you know D of if you want to take 2020. So this we know from this formula which we have done earlier. The 1st March number on the now from here you can calculate the day number on 1st April 2020. How? You will add how many days in this number? 31 days. 31 is congruent to, so that means you have to add 3 to these uh, D 2020. And if you want to go further, say you want to go to 1 of May, then you have to add 30 more days, and 30 is congruent to 2 mod 7. Okay, so you can go on from D of 2020 to 1 May of 2020 by adding 5 more days. Okay, all these things you can write in a table. So these are increments. From 1st of March to 1st of April, add 3 days. Go from 1st of May, you have to add 5 days. If you want to go to 1st of March to 1st of June, you have to add, and so on. Okay, so you can assign some numbers, increments. These increments you can capture by a function of months. If your month is 1st month, okay, then we know the increment should be 0. So corresponding to m is equal to 1. So my claim is this function should be, this whole increment will be captured by this function. Proving this, but this you can check it actually, that for 1st month, if you calculate the value of f of 1, so this would be 13 minus 1 is 12 by 5 greatest integer, which is 2. 2 minus 2 is 0. What would be f of 2? So it would be 5 minus 2, it is 3. And you will see that these are precisely the increments. So these increments you can write down with the help of a function. Is a month and output is a, okay. Then the last step is, now you have to add from 1st March of 2020, you can suppose you want to go to 1st May of 2020, you have to add these many increments. And then further in that month, if you want to go to a particular date, then you have to say D, then you have to add D minus one more days. Okay. So the final formula would be you have to add D minus one more days, and this increment of 13M minus 1 by 5, and this is the Y, the first day on any or first or day on 1st March of any year Y. And when you solve this, you will get this formula. And if you know this formula, then you can calculate the day number or date that is given to you using this formula. Okay, because this formula, this D would be given to you, month would be given to you, and year would be given to you. So that year you can express as a 100 into C plus N, where C is the century, N is the century. So for example, if you want to calculate the day number on 16th of September 2020, so value of D is 16, month is 7 because we are starting from the March. So if you start from March, then from this table you will see that September is the 7th month. So M is 7. Want to calculate 16th of September 2020. So century is the 20th century, and year in that century is again 20. To plug in all these values in this formula, you will get the, and that day number you will see it is 3. So this day is a Wednesday. This is a quite a nice application of congruencies. Okay. Using congruencies, you can calculate day number on any date. Okay, that is given to you. Another application which I would like to speak is a P queen puzzle. So first I will state what is N queen puzzle, and then we will stick to ourselves to P queen puzzle. Okay, in this lecture. So N queen puzzle is a well-known problem in undergraduate program courses. See, the goal of this puzzle is to place N queens on an N cross N chessboard in such a way that no two queens can attack each other. As you know, you must have played chess, and that queen can attack along the row, and then can attack along the column, and that can also attack along the diagonal. To place N queens in N cross N chessboard such that no two queens can attack each other. If N is 2, okay, suppose N is 2, okay, then you cannot, this problem has no solution because you, hello?
You are audible, you can continue.
So if you want to place two queens close to chessboard, so whatever the positions, wherever you place them, they can always attack on each other. Okay, because these are the only possible positions. And similarly for P is equal to 3, you can check this has no solution for N is equal to 3. And for N greater than 3, we will restrict ourselves to prime numbers. Someone is interested, he can, or he or she can look at this problem on Google, that how to solve N queen puzzle. Easy actually, and the solutions are also unique. Actually, there are many solutions for given N, and as the value of N increases, the size of the chessboard increases, the solutions also increase. Okay, so it is not that much simple problem. But in this lecture, I will restrict ourselves to when N is a prime number, where P is bigger than 3. I will produce only one solution, okay, using the help of congruencies, not all solutions. There may be more solutions. Okay, we will just uh, calculate one method. We will see one method to find out the solution of puzzle. And suppose P is equal to 7, then you can see in this table, okay, this is a 7x7 chessboard. Okay, so I have positioned the queens, 7 queens on this chessboard in such a way that uh, they cannot attack each other. Okay, and if you want to find the location of some queen chessboard, that location is captured by two indices, that is, one is I, other is J. Okay, this position is actually first row and fourth column. Okay, so to capture the position of a queen on a chessboard, you need these two numbers I and J, where I denotes the row and J denotes the column. This queen, which is in the first row and fourth column, this is captured by 4 information. Okay, this means one first row and fourth column. And the if you want to see what is the formula to calculate or method to find all these positions for a given I, for a given row, give you a column index J. Okay, and that the index, that position of the column, that column index, that is given by this formula. So J corresponding to, suppose row is I, then in the ith row you have to find J, okay, where you have to place the queen Q. Okay, that J is given by this function, which is f of I. So J is actually f of I. This is congruent to p plus 1 by 2 times I mod p. So suppose you put I is equals to 1, that means you are taking the first row, and then the corresponding column would be actually when you put p I is equal to 1, this would be p plus 1 by 2. It would be p plus 1 by 2 because it is less than p. So for ith, so first row, the column would be p plus 1 by 2. Okay, so first queen that you have to put in this position, and p plus 1 by 2 column. And that is precisely I have done here, because p is 7, so p plus 1 by 2 is 4. If you put I is equals to 1, okay, in the first row, the value of J is 4. So in the 1/4 position, there would be queen Q. Okay. Next queen, if you see from this formula, if you take I is equal to 2, that means you take second row. Okay, then the corresponding column 2 times p plus 1 by 2. What is the meaning of this? That you are adding p plus 1 by 2 times. Okay, so that means the first queen which was placed at in the first row and p plus 1 by 2 column, you have to shift it p plus to the right by p plus 1 by 2 positions. P plus 1 by 2 was 4. Column was 4th. When you shift it by 4 more positions, 4 plus 4 is 8. But modulo 7, that is 1. So that would be the first column. But our row is second because I is 2. So the second queen would be at the, again you have to shift it 4 places, by 4 places in the right hand side. So 1 plus 4 is 5. It would also change. So row would be third, be column would be fifth. So in the 3/5 position, there would be another queen, and so on. So this is the algorithm using the congruencies. Given a prime number greater than 3, you can you always can place in p cross p chessboard. The idea of the proof is by using this function that these, the way we are arranging these queens, they cannot attack on each other. That means they cannot be on the same row, they cannot be on the same column, and they cannot be placed on diagonally. And you first step is, so I will just give you the idea of the proof is, uh, this map is injective map. The injectiveness ensures that these two queens, the way we have placed the queens, no two queens can be in the same row, and that they cannot be on the same column. That is ensured by the well-definedness and injectiveness of this function. And they cannot attack diagonally. So that one important observation that is used in the proof. So diagonal can be our northeast diagonal. Diagonals are these diagonals. So these are northeast diagonals. So important observation is that when you take any northeast diagonal, suppose if you take this diagonal, this position is 1/7 position. When you add the when you calculate the sum I plus j corresponding to this position, this would be 1 plus 7 is 8. Similarly, if you add I plus j corresponding to this position, this would be 6 plus 2, that is also 8. And corresponding to this would be 5 plus 3, which is 8. So if you take any position on this northeast diagonal, you will see that their sum is constant. I plus j corresponding to each position is constant, and that is 8. And similarly, if you take any other northeast diagonal, suppose if you take this diagonal, this is also a northeast diagonal. On this diagonal, the if you calculate the sum I plus j, that would be constant, and that is 9. And that is an important observation to prove that they cannot attack diagonally. And that is the suppose they we will prove that you cannot in this arrangement you cannot put two queens diagonal to each other. Suppose if you put two queens on diagonal to each other, suppose at I1 j1 and I2 j2 position, then by this observation the sum of I1 plus j1 and sum of I2 plus j2, that would be a constant k. Okay, and we know that the way we have arranging these queens corresponding to I1, the corresponding column would be J1, and they are related by this congruence relation. I2 and I2 are related by this congruence relation. And because I1 plus J1 and I2 plus J2, they are constants, they are same constants, and that is K. So when you calculate I1 plus J1, okay, so J1 is actually congruent to P plus 1 by 2 times I1. When you plug in the value of J1 here, you will get P, that K would be congruent to P plus 3 by 2 I1 mod P. Similarly, from the second expression, K is also congruent to P plus 3 by 2 mod P. Because K is equals to K, so that means these two I1 is congruent to P plus 3 by 2 I2 mod P. And you can use the cancellative property of congruencies, which I told you in the very first slide, that, or in the second slide, that to cancel out C from a congruence from both sides, the condition is that you have to divide n by the GCD of C and n. Then you can say that if CA is congruent to CV mod n, then A is congruent to B mod n. So that is property, that property we will use here, that because you can check that the GCD of P plus 3 by 2 and P is 1. Congruence, in fact, you can cancel out P from both sides. Okay. Oh, sorry, P plus 3 by 2 from both sides. Because the GCD of P plus 3 by 2 and P is 1. So you will get equal to 1 by going backward. When you put I1 is equal to I2, you will get J1 is equal to J2. We started with two positions on the diagonal, and we have shown that if we place two queens on the two positions on the diagonal, those positions should be equal. So that means there is no way to uh, uh, put these two queens on northeast diagonals. So there's no northeast diagonal contains two queens, and similarly no southeast diagonal uh, will not contain any two queens, and this justifies mathematically that these two queens cannot attack each other. And the last application of congruence is in the cryptography. So cryptology is the study of secret messages. So in normal cryptography, there are two parties. One secret key, which is known to both parties, and there would be one sender and one receiver. So sender will encode some message key K uh, with the help of some mathematical function f, and that encoded message is called ciphertext C. So C is actually the ciphertext. It is encoded key K and mathematical function F applied on the plain text F. Some ciphertext, and then receiver ciphertext using the same key K and some other mathematical function. You can that receiver will decode this message M this ciphertext C. This receiver can decode with the help of same key K and some other mathematical function G, and that is called the process is called the cryptography. And the example, the simplest example, so I will not go in deep, that is a whole area of cryptology is there, and I will just give you the one of the simplest examples which you can use to encode and decode a message. Okay, so because when you type a message, that will contain the letters from A to Z, then you can give numbers, assign numbers to these letters from A to Z, number 0 to A and 25 to Z. Now if you want to encode some message M, then one of the way is this: you shift these letters by some number. So shift these letters by some fixed position. Okay, suppose if you shift each of these letters from A to Z by three positions, A goes to D, B goes to E, Z goes to C. Okay, and then you can encode this message M with the help of this shifting. New message, say C, from M, okay, by shifting each of its letter by three positions, 26, because there are 26 letters, and because then this would encode the message M, and further receiver can decode it by shifting these positions, by shifting the positions of the letters in C in the reverse direction by three positions. Okay, and that is called the decryption. Basically what we are doing, we are shifting each letter in M by k positions and going modulo 26. Encrypted function. Okay, so this function is encryption function, and you can decrypt this message. So you will get some message, say C. Decrypt C by shifting the letters in C in the reverse direction by k position. So in mathematically, what we are saying is this: your decryption function would be C minus k mod 26. If I ask you to decode this message, 3, okay, and function is same, the shifting function. Decode it. So what actually W, if you take letter T, okay, and shift it by three position, you will go to W. And if you want to go back to original message, then you have to shift W back to 3 positions. So you will get W goes to T in X. And similarly, K, take H and shift H by 3 positions, you are getting K. But now you have to decrypt it. You go back from K 3 positions back, you will get H. You will see when you decode D, it would map to A, and Q will go to N. So this is actually T, H, A, and K and S. And thanks. I will stop here, and yeah, you can now ask some questions.
Thank you very much, Dr. Ajay. It was, I think, the most innovative thank you we have come across so far, and a very mathematical thank you. I convey a heartfelt thanks for this comprehensive presentation about the concepts of number theory and the applications as well. Beautifully presented the applications to the calendar, the chess, and the area of cryptography. I must say to the students as well, it is a very much in demand cryptographers, especially in RAW, in our research and analysis wing. The cryptographers are much in demand. So number theory is rightly said to be the queen of mathematics. Any questions from the audience, please, students? Anyone? You can raise your hand and ask a question. Okay, sir, can I ask you one question, please? Am I audible?
Yes, yes.
Yes, fine. Sir, regarding that application to the calendar, we can also formulate a program of that problem, and we can run it on a system, or we can design app for it.
Yeah, of course you can write a program. Once you know the algorithm I have explained. Now, if you know some programmer that must have that, then you can write down the program also. Yeah.
And sir, are you using any programming languages or any software?
No, actually, pure mathematics in algebra, but my interest is in number theory also. So these kind of applications, I am very much interested. So sometimes I use applications in my class also.
They're very beautifully presented. I hope our students must have benefited a lot from this lecture. Now, I would like to request our head, Mr. Puneet Sharma, to please give a formal vote of thanks. We have a question, 1 minute, please, in the chat box. A student is asking, sir, in the chat box, how to send key to decrypt.
That key actually is known to both receiver and sender in advance. Actually,
okay.
This method which I have explained, in this case, the key which it is known to both receiver and in advance. Cryptography method that is called public key cryptography, RSO algorithm is there. There you can in fact generate key also.
Mm-hmm.
I don't want to go in deep in that direction.
But there is a lot of scope of number theory in these areas. And it is a very, very interesting topic. And the way you have presented it, I must appreciate and congratulate you, sir. Now over to Puneet, sir.
Thank you, Dr. Sargam. First of all, I would like to thank Dr. Ajay from the core of my heart for sparing time from his busy schedule and accepting our invitation as resource person for this webinar. You have delivered such an illuminating lecture. Calendar problems, queen puzzle, or problems on cryptography, etc., discussed in this webinar are excellent examples based on application of mathematics. I hope that your lecture will inspire many students to pursue their career in the field of mathematics. I would also like to thank the management of GDDSD College and our worthy principal, Dr. Balraj Thapar, for their encouragement to organize a webinar on National Mathematics Day. I also thank all students and guests for attending the lecture. Their patience and sincerity for the lecture are highly praiseworthy. Last but not the least, I thank all my colleagues from the mathematics department, specifically Dr. Sargam Vasu and Dr. Mahek Sharma, for their help in arranging this wonderful webinar. Thank you everyone for the successful completion of this webinar. Stay safe and God bless.
Thank you so much.
Okay,
Dr. Ajay, we
thank you.
would love to meet you in person whenever you come to Chandigarh. We would love
Yeah,
to
sure,
meet
sure.
you. Thank you so much.
We'll take leave by thanking the head of department, Dr.